My name is Shelly Tomar. I'm working with Suman Saurabh. Due to limitations of the virtual machine, we have added task 1 at the beginning of the report to help us explain it more effectively. In task 1, we tweaked first.cc so that every simulation run invents its own miniature internet. A 24-bit slice is plugged from 32-bit random number and became the subnet. One launched might live on this IP to the next IP. We also hand the UDP Eco Server a fresh port below 65,000 by drawing from a uniform distribution between 1024 and 64999. Nothing else changed. Two nodes, a 5 Mbps speed, 2 milliseconds point to point link, and a client that fire exactly one packet from 1 second. When we run the script, the trace file showed neat plus NQ event at 234 seconds and matching our receive event 3.7 milliseconds later. Exactly the 2 millisecond propagation delay plus about 1.7 milliseconds of queuing. Grabbing those stamp into GNU plot, give a tidy scatter plot with y is equals to 0 send and y is equals to 1 receive. Horizontal spacing at 1 second interval, a rock solid vertical gap of 3.7 milliseconds. Virtual proof the new random subnet and port have no effect on timing. NetNM confirmed the same thing whichever addresses were chosen. Each datagram hopped cleanly from N0 to N1 per second. Next, for second.cc, we launched the program in one shot with packet size 2048. N packet is equals to 3, delay 15 milliseconds, and NCMA is 10. Creating 10 CSMA LAN node behind the point-to-point backbone, opening the trace in a next editor. We saw the classic ARP handshake at 2.017 S Node 1 broadcast. Who has this IP? And all 11 LAN device received it. Node 11 replies, after which the first 2048 bytes UDP echo packet had to the server appear as 2 IP fragment because of CSMA is 1500 bytes and return a few hundred microseconds later. Tressmetrics said only two hosts actually moved data, node 1, the gateway and the node 11, the server, each around 1.57 millibits per second. Throughputs were a merge 2% protocol overhead gap. So the channel is efficient and loss free. NetNM made the concrete frame 1 show the echo request flowing STA to AP to P2P and to LAN, and frame 2 reverse the arrow from the echo reply with a little blue burst marking Wi-Fi fragmentation and acknowledge. Finally, peeking at the 3 PCAPs in Wireshark and again in TCP dump, let us peel each link layer onion. On a P2P capture, a 1024 byte payload sat inside a IPv4 UDP datagram with only a 2 bytes P2P wrapper. 97% of the Wireshark bit were user data. A Wi-Fi file was a 222 bytes beacon, pure management overhead, SSID, NS3 SSID, a radio tap header full of channel metadata. The CSMA trace held a 64-bit ARP request padded because Ethernet insists on a mini frame size. Dumping the size frame with TCP dump showed identical octet layout. The difference is purely presentation style. Wireshark add color, file name, and a protocol tree, while TCP dump shows a trace hexa and ASCII dump plus brief summarize. Each way, the raw data are the same, and together they confirm that simulation randomized network, custom packet sizes, 10 node LAN, and all behave exactly as theory predict. Thank you.
Okay. My name is Suman Saurabh, and now coming to the part task 4. So let me explain you the code where it is. Let me go through. Yeah. So in this task, we have to create means 4 nodes in which A will send packets to B and simultaneously A will send packets to D. So yeah, finally let me show you the simulation for this one. Is so yeah, you can see this is the network in which we means our code is working, and you can see from 0 the packets are moving towards 1, and it will move towards 1 till 4 second, and after 4 second the A will start means the node 0 will start sending packets to 3, and since there is no channel between 0 and 3, the packets will go through 1. So let me fast forward it. Yeah, so now you can see the bigger packet is moving through 1 and then going to 3. Now after 8 second, yeah, the packet from 0 to 1 will stop. Yeah, now you can see after 8 second the smaller packets are stopped, and only bigger packets which and their destination is 3, only those packets are moving from 0 to 1. Now coming back to code, so yeah, so you can see this is the network where each node is created, and here IP is set for each nodes, and the main part is here the enable bonus. So for part 4 and for the bonus, I have merged both the code into same code base, and I have created a flag. If this enable bonus is 1, then it will print means it will add log flow 1 dot dat and flow 2 dot dat, and from these logs we will create the graph for bonus part. Yeah, that's all.